Hi, this is Pablo from Cabo Labs. In this video, I will show you how to use Atomik Server to feed a front-end dashboard. In this case, we will use data from remote patient monitoring, so it will be basically vital signs. We will start with an empty Atomik server. Here I have Atomik running on my computer. We don't have any health records, we don't have any data, we don't have any queries. What we will do is to run a script that I have prepared here, and that script will create one EHR, so we will have just one test patient, and in that EHR it will create 30 documents with vital signs, basically records from different dates. It will be the same date in this case, but you can think of, a daily monitoring, so measurement of the most common vital signs, that is pulse, blood pressure, oximetry, etc. So in this case, it's just for testing, and since this will be live, I will show you how to load just a few. If I want to set, for instance, 100, this will take some time to load. So the only thing that I need to do is to run this example for loading data, and then to integrate that data into a front-end dashboard. Is open source, so you can actually run it on your computers. If you have an Atomik license, you can find in the website atomik.app how to get a license. So we'll show you while Atomik is loading. You can come here on getting started and getting Atomik. Just remember atomik.app, documentation, getting Atomik. This is still loading, it will take some time. It is actually generating examples and changing the data in those examples. So the data is different on each document, and then loading that to Atomik. So if I reload, now we have one health record, so this is one EHR, and we have 100 contributions here. Contributions mean we created data. Each contribution is kind of a change, for instance, on an EHR. So here we have the EHR, and we have different changes at different times. I can show you some information here in the web console. So this is basically a user interface to see the data that is stored and managed inside Atomik. It complies with the openEHR specification. So here, for instance, let's pick this commit. So we can see that this is a document that contains vital signs. And this is a creation of a document, so it's kind of the container of records of data. One thing here that you might see here is that the loading process also created a query. So this data queries is what we will use to get the data visualized in our dashboard. So right now I will just get here, and this is a different application, is the actual dashboard. The dashboard integrates Atomik through the REST API. It uses the REST API client. It's a separate application. It will run on my computer, but it will be on a different port. And what this will do, this application, while it loads, I will tell you that it will execute this query, and actually we can check this query here. In Atomik, the queries are created using this web interface. I will show you that in a second. So this was preloaded. And you can see that this query is for vital signs monitoring. You can see here the projections. Basically, it will retrieve data that complies with these specifications. So it will be information about the blood pressure, and that will be on this path. This path in openEHR references a specific data point in the model, in the blood pressure model. And I can tell you this is for, and you can see here, the systolic blood pressure. This is for the diastolic, so this is the name corresponding to the node that this path is pointing to. So that is not important, you just care about this is systolic, this is diastolic. The type of this data point is quantity. Quantity is basically magnitude, a numeric magnitude with units. And vital signs are mostly quantities. You can see here we have also the temperature, the pulse, so this is heart rate. Then we have several data points related to oximetry. Yeah, this one, and this one. So I can see that is oximetry. And then respiration, so this will be respiration rate. Yeah. So the query basically is saying you will get this data, and then in the query we can use filters to filter out the data, so we can get this data for one specific EHR, for all EHRs. You want to get, I don't know, maybe 10 data points, you want to get 100 data points. We can define that with different filters and parameters when we are executing the query. So now the application is running. I will load the application. So Atomik is running on the port 8090, and you can see the dashboard is running on 8080. Yeah, it's a different application, can be on a different server. And here, some of the data is hard-coded. For instance, the name of the patient. This information is hard-coded, though that can be also integrated with queries from Atomik. I didn't just do that yet, because the difficult part was really to get, for instance, this data. Yeah, this data is calculated. This is the raw data. So basically, one row here is one of the documents we created, we sent to Atomik to be stored, and each document contains systolic blood pressure, pulse, diastolic blood pressure, pulse, the variability on the pulse. We are not storing that yet, but we could. The breathing rate, information about the oximetry, temperature, etc. We can also calculate different, based on the data, on numeric data, different indicators. Here, where is missing data, we just show dashes. And we also here did just simpler rules, like if the data you see here for instance, blood pressure is outside the normal range, we show red, and if it's outside, kind of far away from the normal range, is red. If it's kind of borderline, near line, it will be shown as yellow. Yeah, and if it's okay, it will just show white. We can customize that, of course. Yeah, this was a small test, very fast coded, so it doesn't have a lot of details, but we could. This is just to show you what we can get from Atomik very easily, and how can we show that information to a doctor, to a nurse, or even to the patient. This could be a patient-facing application. Yeah. Here also just a chart of the same information that is above. We can also kind of add series. We can remove series. Yeah, we can see this data is all fake, but we could see in real data correlations. Yeah, so the blood pressure, the pulse rate, the breathing rate, we can see correlations, our body temperature, and we can say, the patient is, something's happening to the patient in this peak, yeah, or on this valley. Yeah, we can do stuff like that. We can also show other information related with, for instance, the normal ranges. So if we, for each vital sign measurement, we can define, a normal range. We can define a high, a low, or whatever. Sometimes there are multiple ranges. So in this case, this is a toy example, but this can be done for real. This information might not make sense, but this can be done for real. There's some equations there, formulas on how these things are calculated. But this is a pretty basic dashboard showing information that we get from Atomik. I can show you, for instance, this query, actually the source of the data that is displayed here, visualized here, is basically the outcome from this, what is retrieved from this query. So in Atomik, what we have is an internal query builder. So you can build queries from scratch using a user interface without programming knowledge. So you don't need to actually debug your queries. You don't need to compile and deploy the whole application. You just come here and you click on things, and you can select things, or you can define conditions, and conditions can be really complex. You can do simple conditions, you can and or those conditions to make them more complex. The query as it is now, I can click on test, or I can change stuff, and I can click on update. This update will automatically update everything, and when that is updated, the access from the REST API to execute this query and the information that will be retrieved will be also automatically and instantaneously updated. So you don't need to program anything. You don't need to change the code. You don't need to test stuff in code. I mean, here you can test your query. For instance, if I click there in test, I can set some parameters and I can execute. For instance, let me pick and show you. Even though we have just a single EHR, but let me pick one EHR to use as the filter. So here you can say, I want to filter by EHR ID, and just pick data from that EHR. So that is the EHR that we just created. You can also say from to date, stuff like that, filter by date range, and I can execute that query. This will get 20 results. You can sort also the results. And the structure that you will get from this execution, and this is actually what the dashboard is getting, is exactly this JSON. So this JSON has, in this case, headers, a set of headers. Each header is a specification of a data point. So for instance, you will see an archetype ID. In openEHR, archetype ID means from which data model you want that data to come from. In this case, is blood pressure. Then which specific data point you want as in the result is identified by this path. And this is the name associated with this path in this model. Why do we use paths? Because the models are basically trees of data. So a path is a way to identify a specific node in that tree. That's a technical detail. You don't need to worry about that. You just need to worry about systolic, that is a quantity. So these headers will describe all the information returned in this part, the result. So each result is composed by a header that is a metadata. The metadata says, okay, this information that you will get comes from a composition. In openEHR, a composition is a document, a record. This is the identifier of that composition that contains these specific values. This is the EHR ID. The EHR is where the composition is stored. So basically this is a document, and this is the container of that document. Subject ID is the internal or technical identifier for the patient that is associated with this EHR, so the health record. And time committed is when the record was created in the server. Yeah, and you will see that all the time committed values will be very similar because we did the commit all at once, basically with the loading application that I showed you before. Yeah, when this was running, basically it was doing all the commits. I don't know, it took 20 seconds or something like that. So these values will be very similar. So this is the metadata, but the values are really in the projections. So here you have the type of data, then you have a couple of attributes. These attributes actually come from this data type. So a quantity will have a magnitude and units. And the magnitude in this case is this number. The units is millimeters of mercury. You will see the same information as you saw above in the header. What you don't have here, for instance, is the name. So with these two data points, you can come to the header and, for instance, get the name associated with that specific value. Yeah, so you will know that this is, for instance, systolic blood pressure. Yeah, and there is an extra data point in the result that allows you to locate this specific value in the data tree. The data tree is basically the composition, and this is saying, okay, this magnitude with this value is inside this place. And why do we need that? Because if, for instance, in the same composition, you have three different measurements of the systolic blood pressure, for instance, we have at time 0, one measurement, at time 1, maybe 5 minutes later, you have a second measurement of systolic, and then you can have, at time 3, can be after 10 minutes of the first measurement, you can have another measurement. So all of those three measurements will have the same archetype ID and path. So how do we locate the exact place in the data tree, in the composition, for each of those three values? Because each of those should also be associated with diastolic. So we have systolic and diastolic. Yeah, so if you have three values that have the same path, you don't know, or you can't you don't have enough data to associate which systolic goes with which diastolic value. Yeah, with this data path you have that capability, basically. Yeah, so you see this path is 4, this path is 5, and you can see here that you have content 0, data, event 0, data, items 0, and here you have the same parent, so everything until here is the same in both paths. Yeah, the only thing that changes is the item 0 is an item 1 here. So what we can say is that these two nodes are siblings. Yeah, because the item is really the specific systolic and diastolic value. In this case, this is the systolic and this is the diastolic, and both are associated because both have the same parent path. Yeah, if we have three different measurements for systolic and diastolic, you will see events 0, events 1, and events 2 and 2. So the 0, 0 go together, the 1, 1 go together, and the 2, 2 go together. And I can show you actually how that works. So for instance, what we can do is, I have an example here. Let me just show you how this works. This will actually use Atomik's interface, API, yeah. And what I want to do is to use this EHR ID. So I will go here. Here I have a document that contains, you can see blood pressure, And you can have here, for instance, systolic, diastolic, and you can see this is a data tree. This is a document, actually, a composition, yeah? And you can see that there is here events. There is one event with systolic and diastolic. Then there is a second event that has also systolic and diastolic. And we have a third event here. The events are basically the containers of time series data. In this case, we have a series of 3 nodes that have systolic and diastolic. Each of those have systolic and diastolic. Yeah. So what we will do is we will change this URL to use the ID of the EHR we just created. Yeah, and I will try to do that. 204, that means it was created, and I can go back to the query and I will try to get more results, 50 results, and let's see if we got those values. For instance, let me check the value that we sent here is 141 and 93. Yeah, so I will check for 141 here. I didn't get the result. Maybe the 50 wasn't enough, so I will try to reverse the order to get the last created first, because we have more than 50 data points. Yeah, let's see now. We have there, you can see 141, and you can see here 93. Yeah, and that is systolic and diastolic of the same node. Yeah, so we have here, sorry, here, this is diastolic, no, systolic and diastolic of the same kind of, those are siblings, yeah, of the same measurement at the same time. But we got another one and another one, and this is systolic, 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 and we have here diastolic, diastolic, diastolic. So how do we know which node of the systolic corresponds with which node of the diastolic? If you check the data path, you can see that we have here, you can see that this is the same parent until you have the data element. Yeah, the item is the data element. And here you have events 1. So this systolic goes with this diastolic. Yeah, the same here. You can see events 0, events 1, and events 2. So here, if I do something like this, and you can see this diastolic goes with this diastolic, and then the events 2 will be this systolic goes with this diastolic. Yeah. So the client, when the client receives this data, they can reconstruct the data structure, okay, at least to match, you know, which data points go together in the tree structure, so they can reconstruct which nodes are associated. Yeah, without retrieving the whole data structure, because if you have the whole data structure, it will be easier, but it will be a way bigger result you will get in the JSON. So this is the whole data structure for a single document in openEHR. I will show you that if the scroll works here. So this is a composition, and this is a single document. Yeah, it's kind of complex, but if you know openEHR, this is very familiar. Yeah, and you don't need to generate this by hand. There are tools to create this stuff. Yeah, so don't worry about that. But this is one single document. Yeah, we could in the query retrieve the whole document. That's not an issue. Yeah, we could do that. And actually, let me show you how to do that. Let's go back. This is the whole result. Yeah, I just got. Yeah, let's go back to queries. Let me show you how to create a query in Atomik. Yeah, so I will say this is test. Yeah, here you need to add a good name, a good description. The result could be a clinical document or a record, yeah, or an actor. An actor will be a person, because this also stores demographic information. You can store people, organizations, groups, etc. You can store roles, you can store relationships between those actors, yeah, between people and organizations, etc. EHR status of or folder. This is a specific structure at the EHR level that contains metadata about the EHR. Folder is just an internal way to organize compositions. So I will choose just compositions. And here we will use the template. In openEHR, template is basically the definition of the data. Think of that as an schema describing the data structure that you will store and manage and retrieve data from. That's a template. Let's find the vital signs monitoring template, yeah, that I just used. And this shows you the internal structure of that template. It says, okay, this is a composition for vital signs monitoring that contains an observation for blood pressure, an observation for body temperature, heart rate, pulse, oximetry, and respiration. Yeah. If I click on, for instance, blood pressure, here you will see the internal structure of that specific definition. Yeah, just the blood pressure. And you can see here some familiar names, for instance, systolic and diastolic. And let's say that I want all the records that contain high blood pressure. So I will pick systolic. I will go down here and I will say, okay, systolic magnitude, this is the value actually, is greater than 140. Yeah. You can also use variables. Yeah. Instead of setting fixed values, you can set the values for the parameters for the query at runtime. When you run the query, you can provide those values. Yeah. In this case, I will just set the values here. So this is systolic is greater than 140. Diastolic is greater than 90. So this will be the definition of high blood pressure. And I will say this is an OR. So we'll pick both. So in any of those cases, so if this is true or this is true, I will get that result. Yeah. You can also decide if you don't want to get the data, but you want to just count how many documents an EHR has that comply with your condition. You can say, okay, this count is true. Yeah, I will just retrieve data. You can also define stuff like, instead of saying a condition based on values, you can set an exist condition. So if you want just a document to have a document that contains a node, a specific data point that is not empty, yeah, so the data point exists in the data, you can just say exist. And if instead of retrieving documents, you want specific data points, you can add projection. That means I want this data point. For instance, I want just the diastolic, just the systolic. Yeah, you can do that. I want to retrieve the whole document, so I would just put a condition here. And this criteria can be as complex as you want. And you can see that I didn't program anything. This is no code. It's just point, reading names, selecting. So this can be done by anyone. You don't need to be an engineer to create queries in Atomik. You can test this before creating the query. And I can, for instance, filter by the EHR ID. I could just do an open query. Yeah, open queries in general, when you don't filter by an EHR ID, will take longer. So I don't recommend. In this case, it will take the same because we don't have other EHRs. But if you have a million EHRs, filtering by EHR ID means that it will reduce the execution time by a lot. Yeah, and in general, systems that use this kind of repository filter by default by EHRD, because in general the client or the user, the end user, is using a system in the context of one specific patient. Yeah, so this is meaningful. So let's execute, and here what we got is a summary of the documents that contain high blood pressure. Yeah, so I have 1, 2, 3, 4, 5, etc. So they're like 10 or something there. Here you have some parameters for pagination. So if your list is longer and you want all the list, you can just modify the offset and you can get the next 20 and the next 20 and the next 20. Yeah, and this is just how much time it took to get this data from the database. Yeah. If instead of the summary, because this summary tells you this is the ID of the clinical document that contains data that complies with your condition. Yeah, this is when the document was created in the clinical environment. This is the ID of the patient. This is the ID of the EHR. Some extra metadata there. Yeah, not important. If this is enough, because maybe you want your user to know there is a document, but they don't want to see the contents, yeah, that's one thing. Another thing is with the ID, you can get the document. So you don't need to retrieve the full document in the query results. You can just retrieve this, show something to your users, and then your users click on something, and by the ID, you get the full document. But if you want to retrieve the data, yeah, you can just click retrieve data, and instead of getting these summaries, you will get the full data. Yeah, so the full data result is a list of something. That something is a set of metadata. So metadata is the EHR that contains that document, the ID of the patient, the time that document was created, and then you get the document in this key. Yeah, and this is the full document. And if we search in that full document for blood, let's search in the document. Here we have the part of the document that contains the blood pressure information. And if we go down and we search for systolic, you can see that systolic is greater than 140. So this condition was passed because of this. Also the diastolic is greater than 90, but it should be either of those two. Yeah, and here you will see the same number of documents as we got from the summaries, but is the full data of each document with all the data points in there. So you don't only get the blood pressure, you get the pulse, the body temperature, oximetry, etc. in all the documents. It's the whole data, the whole context, etc. And it almost took the same, yeah, because for doing the query in the database is the same logic. Then it's just reconstructing these documents so you get the data back. Yeah, and with the data back, you can just, show that data in an application to the doctor, to the patient, etc. If this works as you expect, you can just create the query, and the query will be stored. And anytime you can come back, you can edit the query if you want, or you can execute the query using the REST API, as we did with this dashboard here, that we used a different query, but it's similar. You create queries, you can create more than one query. In this case, we use just one query to fill the whole screen, this whole screen. Yeah. If you have more complex dashboards or reports, stuff like that, that you want to fill with different information, you can create 10 queries if you want. And it will take you maybe 5 minutes to create each query that you need. Imagine that versus needing to talk with an engineer telling them what you need. They need to go to the database. They need to program the queries. They need to test the queries, doing debug. They need to do some kind of deployment. They need to validate that, go through a QA process. Then they need to compile that several times, maybe. And then, just then, you get your product, your new queries integrated with your product in production. That takes a lot of time, effort, and money. Yeah. With Atomik, you don't need that. You just created, one single query in 2 minutes. Yeah. You can create 1,000 queries if you want, and you can integrate those queries with your user interface very easily. And that could be a web application, a desktop application, can be a mobile application, can be patient-facing application, can be clinician-facing application, you name it. You can do everything with this system. Yeah. If you have any questions, just let me know. If you like this dashboard, if you have any comments, suggestions, etc., we are open to listen to your suggestions. If you want to see and check the code that I used to load the data and actually the code for this dashboard, you can actually find it here. It's open. You can see it here. It's on my user. Yeah, and patient monitoring dashboard. I will add this link to the description so you have it. Yeah. If you have any questions, just let me know in the comments. Yeah. So thank you. Thanks for your time and have a nice day. Bye-bye.